Hello again. So remember what you just heard about the monkeys. I'm now going to take you back to the present, to the real world, and tell you about climate science. So in case you don't know exactly how climate change works, here is a brief summary. So what's happening, let me just see if I can find, So what's happening is that solar energy is coming in. Some of it is reflected by our atmosphere, but most of it is going through to the planet's surface. The surface then absorbs some of the energy, but also reflects it back and emits it back into the atmosphere and back into the cosmos. The problem with the greenhouse gas effect is that greenhouse gases like CO2, N2O, CH4, which is carbon dioxide, nitrous oxide, or methane, are potent greenhouse gases. They build up in the atmosphere and they prevent the energy from the soil of radiating out of the planet. So with an increase in greenhouse gases, we have this greenhouse effect, which means that the back radiation increases, which means that more and more of the sun's energy is being trapped in the Earth's atmosphere. And this causes warming of the atmosphere, global warming. Now we have seen that global warming is a real thing. Most scientists agree that, and they use real data to support their arguments. So this is an image from a study that was published about 2 years ago, and it looked at 18 years of satellite data and changes in sea level all around the globe. The red areas are areas in the world where sea levels have increased. The blue areas are where sea levels have decreased. So you can see that, for example, here in Northern Australia, sea level on average has risen per year over the past, how many years is that? 17 years, by about 10 millimeter, which is massive. And annually, over the average over the whole globe, sea level has increased by 3 millimeters. Despite these observations, there's still plenty of people who don't believe that climate change is happening. Despite 99% of scientists agreeing that this is what's being observed, there's politicians who just don't trust the scientist. There's plenty of people who don't trust the scientist. There's even presidents who don't trust the science. Now, if you have time, this is a great little YouTube video to watch about climate change and everything you need to know in a 3-minute movie. Really recommend that you watch that. I won't play it for you now, but you can go back and watch this YouTube video. Now, the defenders of the climate science stress all the agreements in the data and all the observations that concur that climate change is happening. However, the people who doubt that climate change is happening, or maybe even deny that it's happening, point out that there is evidence lacking, or there are some things that appear to contradict. For example, there's not a direct relationship between CO2, which is one of the greenhouse gases, and changes in temperature. Also, oceans can absorb a lot of heat, which might limit the effects of increased greenhouse gases. It's also been argued that with lots and lots more cities, we may read higher temperatures, but they're not actually higher in the rest of the atmosphere. Also, it's been argued that if greenhouse gases are trapped in the atmosphere, it's not just trapping the radiation that's going out, but also limits the radiation that's going in. I'm telling you these arguments so that you're prepared to refute these climate change deniers or climate change doubters. And I will show you that there is lots of data and evidence that climate change is actually happening. So let's look at a couple of observations. And I'm going to work through these graphs with you so that you learn to interpret data that's presented to you. It's really important that you're able to read graphs if you're studying science. So what I'm showing here is the deviations of the northern hemisphere temperature from their mean over a reference period. So the reference period is 1960 to 1990, which is a 30-year period, chosen by the World Meteorological Organizations, and all reports are showing how the average temperature that's being recorded is different from the average temperature in that base period. What does that mean? So the 0 is the average temperature in 1960 to 1990. And each dot is the average temperature on the land surface measured that year and how much different it is from that base period. So you can see that 1940s and before the 1940s, the average temperatures were in general lower, the temperature deviation was negative, than the temperature on average in that base period. In the base period, it kind of hovers around the 0 mark. But then, after the 1980s, you can see that the deviations of annual land surface temperature are positive. This means that, on average, there were higher temperatures recorded compared to that base temperature range in the from the 1980s onwards. Now, how is this related to data analysis? So what you can do is you can analyze whether these differences, whether these deviations are statistically significant and different from 0. And we want to know whether there is a trend happening over time. And you can do that by estimating a linear model and a trend model, which I've done for you in R. I've given you here the R code, but I'm not going to discuss that because that's what the tutorials and James' lectures are for. But what I have done is I've taken all the data from the Northern Hemisphere temperature deviation, and I have done a linear regression, where are we? There we go, of the temperature per year. And that just creates a trend line. A line that shows linear regression, that on average these dots are going up. You can see here, the red line is the trend line, and it's going up every year by 0.01123 degrees. So that gives us some indication that maybe temperatures are really increasing. Now, you've done enough statistics now to realize that just a trend line isn't enough. We have to do a formal test to see if this linear model has really does have a positive slope, and whether that slope is significantly different from zero. So that's what I'm going to test. I'm going to test the null hypothesis that the slope of this trend graph is zero against the alternative that it's not equal to zero. That's what I'm doing in this bit of R code. I'm doing sorry, I keep losing my mouse. Linear model of the Northern Hemisphere temperature data per year. And here we go. It's a bit easier. And that gives me an estimate of that linear function. So first of all, the coefficients. That's the trend line with an intercept and the slope. The slope still the same, 0.0112. Those are the coefficient estimates. Standard errors are also in your output. They give an indication of the uncertainty in those coefficient estimates. The t-values. So those are the t-test values that you've calculated before. Also gives you an indication of the uncertainty in the coefficient estimates. And finally, the p-values. We can use those p-values to decide whether the slope is significantly different from zero. Here you see the p-value for slope, the year coefficient, is smaller than 2 to the e minus 16, which means that it is very, very small, 0.00000, 16 zeros to, and then 2. A lot smaller than 0.05, which is the value that we evaluated against. So we reject the null hypothesis that the slope is equal to 0, which is not good. Why do we care? Well, if the slope is 0, there isn't really a trend. But if it's positive, there may be a trend in upwards temperature. So that was a long stretch. So have a break. I have this really cool little video for you, which is showing how temperature has changed in the past 116 years. 4 different countries. Let's see if it plays. Did you find that scary? Let's have a bit of a break and then you can watch it again if you want.